In this lesson, we'll go over two different forms for the equation of a line. And we're going to start with the point-slope equation, which is given by this. Y minus y1 is equal to m times x minus x1. So here x1, y1 is any point on the line, and m is the slope. Maybe just a quick thing about where this formula comes from. If you take this equation, which is, again, y minus y1 is equal to m times x minus x1, you can solve for m by dividing both sides by x minus x1. So divide this to both sides. And on the right, we can cancel those common factors. Here we don't have to include the parentheses anymore. And what we have is y minus y1 over x minus x1 is equal to m. And this is actually the formula for slope, the difference of two y values divided by the difference of two x values. The only difference is that this x and y could represent any point on the line, and the formula for slope, we chose another specific point. All that being said, in example 1, I want to find the point-slope equation for this line. So all we need to know is two things: any point and its slope. Let's start with the slope. If you want to find the slope of this line, I'll use a more simple definition, the rise over the run. So starting with this point, the rise is 1, 2, 3, 4, 5, 6. So you go up 6. And the run is 1, 2. And this gives us a slope of 3 over 1, or simply 3. The next thing we need, since we have the slope, is some point x1, y1. And I think I'll choose this point here. This is the point 1, 1. So my x1, y1, I'm choosing to be 1, 1. The last thing to do is put all this information in, and what we have is this. Y minus, this is y1, so I'm just going to put in the number 1. That's equal to 3 times x minus x1, which is also 1. And that's it. Here it is. This is the point-slope form of the equation of this line. Now, I have this other point here. Could I have used that point as well? And the answer is yes. You can use any point on the line that you would like. So let's try it again. This time for the x1, y1, we'll choose this other point, which appears to be, that's -1, -5. Okay. If we put this into the same equation, we get y minus, y1 is really -5 this time. And this is equal to the slope, which is 3, times x minus x1, which is -1. I'm just being careful because since we're doing a minus, I just included some parentheses. Of course, this minus a minus, and this minus a minus can be written as plus. So just to continue over here, we can write the equation as y plus 5 is equal to 3 times x plus 1. And here we go. This is, I guess, also the point-slope equation of the line. So notice that these are different, and either one is acceptable, but both of them actually give you this equation here. You only need to supply one answer, so you could choose the one that you like, but I just wanted to go over it in two different ways. The other form of the line that I wanted to go over was the slope-intercept form, which is y is equal to mx plus b. So here m, again, that's standing for our slope, but b represents the y value of the y-intercept. So using this form of the equation and the same line from the previous example, can we come up with the form of the line written this way? Well, I already know the slope from the previous example. We found the slope was 3 over 1, or simply 3. The next thing we need to know is, well, what's b? What is that equal to? If you know b, you can just put that number here, and you're basically done. So here's the line. B is the y value of the y-intercept, which is right here, and that appears to be -2. And to get our equation, we're basically there. That would be y is equal to 3x, and you can put plus the -2, but it probably makes more sense just to write, y is equal to 3x minus 2. So here it is. This is the slope-intercept form of the equation. But before moving on, well, we now have three different equations. On the previous slide, I believe we had y minus 1 was equal to 3 times x minus 1, but we also had y plus 5 is equal to 3, I think it was times x plus 1. I mean, are these all the same, these three different equations? They should be. What you can do is, let's say, take this first equation, distribute the 3, add 1 to the other side of the equation, and see if it matches up with this thing. Let's try it out. So that is, if we have y minus 1 is equal to 3 times x minus 1, if we first distribute in the 3, we get 3x minus 3. Hey, and if you add 1 to both sides of the equation, you get 3x minus 2. So, that matched with this. What about this other one? Y plus 5 is equal to 3 times x plus 1. If we distribute in the 3, we get 3x plus 3. And if we subtract 5 from both sides of the equation, we again get 3x minus 2. 3 minus 5 is negative 2. So it turns out that all of these equations are in fact the same. But in any case, they all would give you this line if you tried to graph it. So in this last example, I'd like to find the point slope and point intercept equations for a line with slope a half, and that goes through the point 8, 5. Because we're given the slope and a point, that is, we're told m is equal to 0.5, and we have a point x1, y1 is equal to 8, 5, it makes sense to start with the point slope version of the line. Y minus y1 is equal to m times x minus x1. And I'm going to simply just plug in this information. So we have y minus y1 is 5, so that was right here. That is equal to the slope, which was 0.5, and then we have x minus 8, because 8 was x1. And here it is. This was the first thing. This is the point slope form of the line. But how do we get the other one? So how do we actually get the point intercept? To do that, basically what we can do is distribute in the 0.5 and add 5 to the other side of the equation. So let's try that. So again, we have y minus 5 is equal to 0.5 times x minus 8. If we first distribute in the 0.5, we get 0.5x minus, 8 times 0.5, half of 8 is 4. The last thing to do is add 5 to both sides of the equation. And if you do, you get a plus 1. So this first one was of the form y minus y1 is equal to m times x minus x1. And this one here is in the form y is equal to mx plus b.